In this video, section 2.7, we're going to be talking about transformations of functions. And what this means is, how do we take a parent function that we saw in the previous video, how do we shift that function around the coordinate plane? So there are many types of transformations that we could do. We're going to talk about 5 of them. The first is a horizontal transformation. And a horizontal transformation given by, well, let's say we have y equals f of x. If we have y equals f of x minus c, this shifts the function right c units. And if we have f of x plus c, this shifts the function left c units. So let's look at an example. Suppose we have y equals x squared as the parent function. If we want to shift this, let's say left 2 units, what we're going to say is we'll have y equals x plus 2 squared. Okay, so that's kind of following this rule here. If we want to go right, let's say 5 units, what we're going to do is we'll say y equals x minus 5 squared. So we're following this portion of the rule. For a vertical shift, this just moves a function up or down. So if we have a function and we add c to it, that's going to shift the function up c units. If we subtract c, we're shifting the function down c units. So let's look at an example here. If we have y equals, I don't know, x cubed as our parent function, if we want to shift this, let's say up 5 units, what we would do is we'd say y equals x cubed plus 5. And let's say we want to go down 3 units. We're going to say y equals x cubed minus 3. A third type of transformation is called a reflection. And there's 2 different ways we can reflect a function or its graph. We can reflect about the y-axis, we can reflect about the x-axis. So if we're reflecting about the y-axis, to do this, what we do is we change the input into the function and we just make it negative. So if we start with f of x, we want to find f of negative x. A reflection about the x-axis, well, we take our function, but we multiply it by negative f of x. And I'm missing a y here, so y equals negative f of x. Negative f of x. Okay, so let's see how this works. So an example of this, suppose our function is y equals x cubed, and we want to reflect this about the y-axis. What we'd do is we'd say y equals negative x cubed. So we'd want the negative inside the parentheses there. If we wanted to reflect this about the x-axis, let's use the same equation. What we're going to have is y equals negative x cubed, but that negative is outside. It's outside of the parentheses. In other words, this negative is not getting raised to the 3rd power. So our function is going to look like that if we want to use parentheses. So it's a subtle difference, but if we want to do any y-axis or horizontal reflection, we want to change what's inside the function. If we want to have any vertical reflection, we change what's outside the function. So we change that negative, or make that negative outside of the function there. The 4th transformation to look at is a vertical stretch or a vertical compression. How this works is we multiply the function by some constant a. So if we multiply the function by a, this tells us we have a vertical stretch or compression, and a is the factor that we have the stretch or compression by. So if a is greater than 1, we have a stretch. If a is between 0 and 1, we have a compression. So let's look at a quick example. So y equals x squared. Let's say we multiply this by 3. What this would be is a vertical stretch by a factor of 3. And practically what this is going to look like is if the original function is a parabola, the stretched function is going to pull the function up at a steeper level. So the stretch is the blue part here. All right, and then let's suppose we have, again, y equals x squared as the parent function. Suppose we have y equals 1/2 x squared. So this is going to be a vertical compression by a factor of 1/2. So again, practically speaking, if our original function looks like this, if we're compressing this by a factor of 1/2, it's like we're smashing it downward. So it's going to be spread out more. That would be a vertical compression. Now the last transformation to discuss would be a horizontal stretch or compression. Here we're going to multiply by some factor, but the factor that we multiply goes inside the function. So if we multiply by a factor b, that tells us we have a horizontal stretch or compression. Now if b is greater than 1, we have a compression. If b is between 0 and 1, we have a stretch. So this is kind of the opposite of what's happening with the vertical stretch or compression. So let's look at a quick example. If our parent function is y equals x cubed, if we multiplied this by, let's say, 4x cubed, what this is going to do, well, 4 is greater than 1, so we're going to have a horizontal compression. So horizontal compression by a factor of 4. So again, what this means, x cubed, the graph of x cubed looks like something like this. So if we're compressing this horizontally by a factor of 4, what's going to happen is we're going to squeeze this horizontally together. So it's going to look something like this. Maybe not as, maybe more dramatic than that, but it's going to get squeezed horizontally. And then similarly, if we have y equals x cubed, if we multiply inside here by a factor that is between 0 and 1, we're going to have a horizontal stretch. So this is a horizontal stretch by a factor of 1/2. So what this does to the graph, again, x cubed looks something like this. So if this is a horizontal stretch, we're going to be stretching out side to side, so stretching out horizontally. So this will be a little bit flatter, and then it'll come something like that. Imagine that was a perfect graph, but you get the idea. So let's look at a few examples of this. First one says, describe the transformations that produce the graph of f of x from the graph of the parent function. Well, first of all, what's the parent function? The parent function here is going to be 1 over x. So we see is that this plus 2 is the transformation. Now, this plus 2 is inside the function, and anytime we add a value inside of a function, that is a horizontal shift. So this is a horizontal shift, and we are going left 2 units. Okay, so if we were to look at this graphically, the original function looked like this. So that's the original function, 1 over x. If we want to shift this to the left 2 units, it's going to look something like this. Okay, so that would be 1 over x plus 2. On this function, we have f of x equals negative of x plus 1 cubed plus 2. So the parent function here is f of x equals x cubed. So we have a few different transformations happening. We have this negative sign, this plus 1, and the plus 2. So let's start on the inside of the function and work our way out. So this plus 1 is a horizontal shift of left 1 unit. This negative sign in front of the function is a reflection, and this is a reflection about the x-axis. So reflect about the x-axis. And then this plus 2, this is a vertical shift, and this is a vertical shift up 2. So up 2 units. So let's look at the graph of what we have here. So the original function, x cubed, is going to look something like this. And again, it's kind of hard to graph using this stylus, but that's going to be x cubed. Now what we want is we're going to shift this left 1 unit. So left 1 unit, and let's just do this piece by piece. So left 1 unit is going to be like this. Okay, so that function, the red function, is going to be x plus 1 cubed. Now if we reflect this, let's say the reflection, we'll use a different color. So this is going to reflect across the x-axis. So it's going to be something like this. Okay, so this is going to be negative x plus 1 cubed. Okay, so the negative sign reflects. And then we're going to shift this up 2 units. So everything is going to get shifted up. So this will be something like this. Okay, so it's shifting up 2 units. Not perfect what we're seeing here, but I think you get the idea. So this is negative of x plus 1 cubed plus 2. So there's 3 transformations that are occurring here. This next one, we have f of x equals 2 times the cube root of 1 minus x plus 4. So the parent function here is f of x equals cube root. So this is the cube root function. Now what we have is this inside here, sometimes we may see this written like this instead, and I think it might be easier to see what's happening. So that negative, the negative sign right here, that corresponds to a reflection across the x or the y-axis. Okay, so starting inside the function and working our way out, so we have a reflection across the y-axis. This plus 1 is a shift 1 unit left. Okay, this positive 2 that we're multiplying by, this is a vertical either stretch or compression. For a vertical stretch or compression, if the number that we're multiplying by is greater than 1, this is a vertical stretch. So we'd say vertical stretch by a factor of 2. And then this plus 4 here is a vertical shift up 4, so up 4 units. Okay, so what we have is we have 4 different transformations here. Now I'm not going to graph this one, but if you wanted to, the parent function, x cube root of x looks like this. So that's cube root, or I'm sorry, not cube, we want cube root. All right, and then once we take into account all the transformations, the graph will look something like this. So this graph looks something like this. Now it's not perfect, but this is the new function, f of x. So it reflects across the y-axis, so it's no longer increasing, it's decreasing. I shifted this left 1 unit, up 4 units, and then the vertical stretch by a factor of 2, which is hard to show here. This last one, we have f of x equals the absolute value of 1/3 x minus 2. So the parent function is the absolute value function. We have two different transformations. We have this 1/3 and this -2. So the 1/3, that's going to be a horizontal, either stretch or compression. Horizontal. Okay, stretch or compression. Because it's 1/3, because we between 0 and 1, this is going to be a horizontal stretch by a factor of 1/3, and then this -2 is a vertical shift down 2 units, so down 2 units. Okay, so this one, there's not too much going on, so the graph will be easier to see. So the regular absolute value function, let's use a different color, looks like this. So that's absolute value of x, and if we want to see the transformations, and the transformed graph will look like this. So 1/3 x minus 2. Okay, so we're shifting down 2, and then that horizontal stretch is going to stretch out the graph side to side. And let's check out a couple more examples. So the first thing we want to do for this question is figure out what the parent function is, and the parent function is x squared. So we have two different transformations that are happening. This 2 says we're going to shift left 2 units. Let me write that in a different spot here. So left 2 units, and then the 4 tells us we have a horizontal compression by a factor of 4. All right, so let's look at the parent function first. So the parent function is just x cubed. That's a parabola centered at the origin, 0, 0. So something like that. Now we need to apply these two transformations. So the new vertex is going to be down here, and this is a horizontal compression, so this is going to be more narrow. So something like this. So this will be the new function 4x plus 2 squared, and this is the original, or the parent function. All right, and then these last two, we are given all the transformations in words, and we need to come up with the function. So we're starting with f of x equals x cubed. So let's just take these one step at a time. So 4 units left, 4 units left. What we'd have is f of x equals x plus 4 cubed. Stretched vertically by a factor of 3. So vertically by 3, what we're going to see here is we'll have f of x. Now any vertical stretch or compression goes outside the function, so this will be 3 times x plus 4 cubed. Reflected about the y-axis, that will be, since we're reflecting about the y-axis, is going to be inside the function. So the y-axis is also a horizontal reflection, so anything horizontal, any transformation that is affecting the function horizontally goes inside the function. And then 2 units down, we're going to say f of x equals 3 negative x plus 4 cubed. 2 units down, we're going to say minus 2 on the back end. Now, one way you can check your work on this is graph the parent function and then graph the final function and see if each of these transformations appears in the graph. And the last one here, it says start with f of x equals square root of x. If we're shifting 3 units right, we're going to end up with f of x equals square root of x minus 3. reflect about the x-axis, we would get f of x. And what we do when we have a reflection about the x-axis, or in other words a vertical reflection, that negative sign goes outside the function. To shrink horizontally by a factor of 4, this is the same thing as a compression. Okay, so compression by a factor of 4, this is going to go inside the function. So we're going to see that we have 4x minus 3. Any horizontal compression or stretch goes inside the function. And then lastly, up 1 unit, we're going to say f of x equals negative square root 4x minus 3, and then we put a plus 1 on the back end.